Welcome to my channel of maths videos. My name is Karen Daly and I'm a mathematics lecturer at Dundalk Institute of Technology, a third level college in Ireland. This suite of videos was produced to help students beginning their third level career brush up on their basic mathematics skills. This video is on scientific notation. Enjoy! In many areas, we regularly have to deal with numbers that are very large or very small. Here's an example of a very large number. It's the speed of light. It's given in meters per second, and this is the number here. This number here is written in decimal form, so I'll write that down for you, just so you remember. This is called decimal form. Scientific notation is just another way in which we can write this number. So how do we do this? Well, firstly, we reposition the decimal point. So the decimal point is understood to be here, and we move it to this position here. So let me write that down. So it's going to be 2.99792. In repositioning the decimal place, I've made the number much smaller. So what I have to do is, I have to return it to its original size. So I'm going to multiply it by the appropriate number of tens. So let me count how many tens. The decimal point is here, so I have to move it 1, 2, 3, 4, 5, 6, 7, 8 places. So in effect, I have to multiply it by 10 to the power of 8. So an important thing to note is that these two numbers, this one, right, and this one, are actually representations of the exact same number, the only difference being that the top one here is written in decimal form and the bottom number here is written in scientific notation. One further thing I would like you to note is that for a number to be in scientific notation, this value here will always be a single digit and it won't be a zero. And also that this value here will always be a whole number. Let's look at another example. It says write the following number in scientific notation, and the number is given here. Again, just to remind you, the number here is written in decimal form and it's a very big number, as you can see. Okay, so let's write this in scientific notation. So the first thing is to reposition the decimal point. So the decimal point is here and we're going to reposition it into this position here. So let me write that down. The number is going to become 4.2. Now to maintain the correct size of the number, I multiply it by 10 to a certain power. So let me go back and check how many powers of 10 I have to multiply it by. The decimal point is repositioned here, so if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to have to multiply it by 10 to the power of 12. So now my number is in scientific notation. This is written in scientific notation, so this is the answer to the question. And just to remind you then that this number here in scientific notation and this number here that was originally written in decimal form represent the exact same number. So can I ask you now to pause the video and try this problem yourself? How did it go? Does your answer look like this? In scientific notation, the first thing you have to do is reposition the decimal place. So when you did that, it should look like 6.0221. Then to maintain the size of the number, I have to multiply it by a certain number of tens. So you're going to have to count all them zeros back to the original decimal place, and what you should get is 10 to the power of 23. Now let's have a look at how we represent very small numbers in scientific notation. Here is a number which is really small. It's the charge of an electron in coulombs. Again, this number, as it's written here, is written in decimal form. Decimal form. And what we're going to do is, as before, we're going to rewrite this number into scientific notation. So just as before, our first step is to reposition the decimal place. So the decimal place is here, right? And we're going to reposition it over to here, right? So then let me just write down the number then, as it would appear, is going to be 1.60218. Now this number that I've just written down and the number above will have to be the same size once I'm finished. So just like before, I'm going to have to change this number by multiplying it by 10 to a power. So just like before again, the decimal place is here now. And if I count the number of tens that it takes to get back to its original position, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So to go from here back to here, what I've had to do is I've had to divide this number by 10 19 times. And in mathematics, how we represent that is we write it as by 10 to the power of minus 19. So when I multiply 1.60218 by 10 to the power of minus 19, what I'm actually doing from an arithmetic point of view is dividing 1.60218 by 10 19 times. So just like before, this is the answer now in scientific notation, and this is exactly the same number in decimal form. Also, for your own understanding, when a number is expressed in scientific notation and you see that the power on the 10 is a negative number, you should always remember that this number then is a small number. Right? If the power on the 10 is a positive number, then the number will be a large number. Try this question yourself. Write in scientific notation this number here. Pause the video, try it yourself, and then come back to me and see if you got the right answer. Hopefully that went okay for you. So let's have a look at the solution. Right? So in scientific notation, so the first thing that you did was you moved the position of the decimal point. So the number now becomes 3.453. Okay. Then to maintain the size of the original number, you have to multiply it by 10 to a power. Now the original number is much smaller than this number here, so the power is always going to be a negative. And if you count the number of positions that you move the decimal point, you will find that you move them 14 times. So this is the solution. This is the number in scientific notation. So if I was to write what I have been doing in a slightly more formal way, I would write that a number is written in scientific notation if it is written in the form a multiplied by 10 to the power of n, where a is any real number between 1 and up to, but not including 10. In mathematics, we would write this as a is less than 10 and greater than or equal to 1. And then n is a positive or a negative whole number. Let's look at this question here. Write in decimal form the number 3.614 by 10 to the power of 10. Now that's a number in scientific notation, and you want to bring it back to its decimal form. Now this is a positive 10 that you asked that's on the power of 10. So to do this, all I will do is I write down the number without any decimal point, 3614. Right? Now the decimal point has originally been here. So what it says to me is multiply that number by 10 10 times. So I start multiplying by 10 once, twice, 3 times. Now I need to multiply it by 10 another 7 times. So 4, 5, 6, 7, 8, 9, 10. So when I multiply, that's 3, 4, 5, 6, 7, 8, 9, 10. The decimal point will move to here. Now normally you wouldn't display that decimal point. So the solution to this is in decimal form. This number is 3,614,000,000,000. And as you can see, this is a very big number. A big number. Now let's look at this question here. Write in decimal form again this number here. Again, it's by 10 to the power of, in this case, minus 10. So let's write out the number again. So I'm going to write it over to the right hand side. It's 3,614, right? The decimal point was originally here. And I have to multiply it by 10 to the minus 10. Now, multiplying by 10 to the minus 10 means that I divide by 10 10 times. So I start dividing by 10, so once, right? Now I'm going to have to divide by 10 another 9 times. 2, 3, 4, 5, 6, 7, 8, 9. So if I continue on dividing it once, twice, 3, 4, 5, 6, 7, 8, 9, and one more, 10, right? 10 times, the decimal point appears here. Okay, so it's moved from here to here. So if I was to write the solution to that, what I will get is that the solution to this problem here is that the answer is 0 point, and I'm going to have 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I'm going to have 3, 6, 1, 4. So as you can see, this is a very small number, right? So like I had emphasized earlier, when the power on the 10 is a negative number, which it is here, the number in decimal form, the number is a very small number, so as you can see, that's exactly as it is in decimal form. So what I'd like you to do is to again pause the video for a few moments and try this question yourself and see do you get the right answer. So for part 1, you're multiplying it by a positive power, so you're just multiplying it by 10 7 times. And if you multiply 5.639 by 10 7 times, you'll get 5, 6, 3, 9. That's multiplying it by 10 3 times, and another 4, 1, 2, 3, 4. Okay, you can count them 1, 2, 3, 4, 5, 6, 7. So that's the solution there. Now for part 2, here you've got this number here, and you're going to be multiplying by 10 to the minus 9, which means you'll be dividing it by 10 9 times. So if I take this number 2316 and I start dividing it by 10 9 times, I'll end up with 0.80, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 zeros. You can count them. When you started here, divided by 10 once, twice, 3, 4, 5, 6, 7, 8, 9 times. That's where the decimal point ends up. So that's the decimal form of that number there. You may have found yourself asking the question, why use scientific notation? Two main reasons. Firstly, scientific notation is a tidier method of displaying a number, and also you can read the size of the number much more readily when it's in scientific notation, because the size of the number can be seen from the power on the 10. Secondly, scientific notation allows you to enter much bigger numbers on your calculator. Your calculator screen is on your calculator screen you can only enter up to 9 digits. So how would you enter a 34-digit number? Well, one of the ways, or the way around this, is to use scientific notation.